That being the case, whenever you're ready, can you talk through what you've put together?
So basically, we have a system where you can grow your own tree. You can add fertilizer by pressing this button, and fertilizer falls from the sky. As you can see, as you add more fertilizer, the fertilizer bar goes up. When you let it go, the fertilizer bar goes back down at a rate. And then same with rain, you can get it to rain.
Cool.
Similarly, water bar that goes up at one rate and goes down at a slower rate. Fertilizer goes up at the fastest rate, water goes up at the second fastest rate, and then sun, that parameter is one adjusts the position of the sun, and then the other adjusts the actual size or intensity of the sun.
Oh, wow.
So at a higher intensity, well, actually, we start from it being lowest. At the lowest intensity, the sun bar goes down. You can bring it up to a higher intensity and get it to stop changing at all. And then if you increase beyond that intensity, it starts increasing again.
Okay.
Alright, so we'll just go through and play the game one time so that you could see how the actual tree grows. So at the very bottom, there is a very small branch. So now as the sun bar increases, the branch starts growing more. However, adding rain and then potentially fertilizer will help the branch grow faster, the branch grow taller, and then at some point, the branch will branch off into multiple children. And this is a random amount between 2 to 4. So at each node, which you'll see eventually, the program essentially chooses whether the children will be a branch, how many branches there are, and whether it also wants to produce a leaf. So right now, the main stem is still growing, but different initial conditions, aka how much fertilizer, how much water is given, will also impact that. So now you can see that the program has chosen 3 branches.
Cool.
And then we're just letting it grow on its own for the time being. But as you can see, the rate of growth has slowed down significantly because fertilizer is going down and the water level has also gone down.
That's when the first leaves have grown. And as you can see, it's also growing towards the sun more directly now because we have it such that while the tree is growing, it calculates a net growth direction for the plants and leaves for the leaves and branches to grow at. And this is calculated by taking the position of the sun, something else we have called the tilt parameter, and what will happen is, and also there's also a third random parameter. So the sun parameter takes the position of the sun and calculates the angle in radians and fix, and it'll also, the same thing is true of the tilt. They're both read from this these 2 potentiometers here.
Okay.
And how they work is that the sum of them together is weighed by 20% of the total net growth direction. And like Fiona said, when one's maximized, the other is absent. So if you've got maximum sun right now, the component that total component is only applying 20% of its direction towards the sun. So you'll see that there's a mean growth direction towards the sun. The same would be true if the tilt parameter is in one direction, but the sun is all the way down. It would follow the tilt parameter more exactly. So we're going to show that here.
Okay.
So since the sun is, actually, wait, let's turn the tilt to the right so you can see, oh, it's to the right? So yeah, see the sun's over here now, and we've turned the tilt all the way to the right. So the mean growth direction should be closer to 45 degrees from vertical here. And of course, this one wants to be not so nice, but this is part of the third component, which is a randomly generated component.
Sure.
So the randomly generated component is pretty interesting because it's not just picking a random angle between like a given range. It's what it does. It generates a random number between 0 to 120, and has it about 0, so that it's generating either between plus and minus 60. What it then does is it takes that angle and adds it to the angle of the previous branch. So what happens is the branches will always have some continuity because it can only be within a certain deviation away from it. And the result from there is that it looks like a continuously growing branch even when it starts to grow downward. So that is weighed by 80%, where the sun and tilt are weighed by 20% total.
Okay.
Yeah, and as you can see in this iteration, a lot of the branches are towards the right, and then the random component allows some branches to be a little bit more rogue.
Yeah, so you get a nice, more natural spread despite there being a mean direction in one area.
And is it also the decision of a node as to whether or not it becomes a leaf? Is that also randomized?
Up until a certain point, it is randomized. So at the lower levels, we did not let any leaves spawn off of this one, just
Right.
because sometimes it would result in absolutely no branches coming off at all.
Right.
16 chance.
Because we don't let anything grow off of a leaf. But at some of the higher nodes, you can see that there's a leaf here.
Yeah.
That is randomly, it's rand mod 2, so it's a 50-50 shot of, roughly, of being a leaf or a branch. And then most of these end with leaves at the end of the branches.
Yeah, that's the
Neat.
maximum depth. So at all maximum depths, it has to be a leaf.
Okay. So if a particular sort of growth path happens by chance to be branch all the way down to the maximum depth, it will ultimately
be a leaf,
it'll
yes.
terminate with a leaf. Okay.
Because it does have to stop growing at some point,
Yeah.
and also the Pico's memory limited. So regardless, it will run out of nodes to generate.
Sure,
So
okay.
regardless, it will stop growing at some
We
point.
came up with that issue earlier, and I have to say this because I spent so long on it. I made a what we were talking about before is that we had a method that would take all points on the tree and rotate them about the base of the tree.
Right.
So we made a whole rotation matrix system and took every single coordinate of the branches in VGA display, and we had them rotate about that point. I spent so long on it; it was over 100 lines of code, and it took up too much memory. So we didn't get to use it. And the
Okay.
worst part was it was functional too.
Okay.
Wait, actually, can we generate a really big one? Because
Yep.
I was like, a lot of the ones that we're showing are kind of small, so
It'll take a
You know,
minute, but yes.
yeah. So essentially, this is the final condition we want to show. Where
Uh-huh.
do we also want to do maximum sun or no?
Sure, we can do max
Or
sun.
yeah, sure. I just know the sun also has some impact.
So
on
by
it.
changing these various parameters, you're able to affect the growth rate, the growth direction, and then the ultimate size to which it grows. Is that
Yes.
correct?
Yeah.
Okay.
So right now Fiona's holding both the fertilizer and water buns to continue making it grow, and you can see the stems really getting a
Yeah.
lot taller than in the previous iterations.
This water is it modifies the maximum branch length, and that allows plants to be a lot taller and take up much more of the screen.
So yeah, it's still going, but
The animations are nice too. The rain is a nice effect, and then your fertilizer, it's a good illusion that it's like being dropped on the top as opposed to the rain that it appears to be falling at terminal
that's all thanks to
velocity.
Fiona. So
Yeah, it's really nice.
yeah, and still with bigger tree structures, it still grows semi-slowly just because it is bigger.
Yeah. So do I understand correctly that you've specified sort of a maximum tree size so as not to exceed any memory limitation?
So we basically created a memory pool that limits the number of maximum nodes. We created this array structure that holds all of the tree nodes that are possible, and then if it exceeds that amount, it just won't allow it to continue growing. So really,
neat.
at some point, the animation is just updating to make sure that, as you can see, the fertilizer's dropping. There's some black dots on the screen wherever it drops.
Yeah.
So it just gets reanimated to ensure that, it's still on the screen.
Okay.
So yeah, but that fixed a lot of our memory issues, and I also did play around with different node size, like array sizes. So we kind of sat at a sweet spot of around 1750.
Okay.
As low as 1500 also looks fine. It's all right, but the more nodes that are possible, the more complex you can get. The bigger trees you can get, you could also increase the number of children. However, even with this many, where we specify the number of children between 2 and 4, and also the number of nodes being 1750, it still looks pretty good.
So, and we saw this appears to have a decided bias in growth direction toward the sun.
Right, since the sun's intensity is really high this time, so it goes more towards the left.
It's really nice. Really, really nice. The color choices are nice too. It looks really pretty.
I mean, unrelated to the demo, I did take some photos of actual trees on my walk over
Oh,
here.
nice.
Have them modeled after.
So this is a real tree walking over here, and another one that's a little bit more sparse, but it looks pretty similar to
That
maybe...
is certainly artistically kind of. Yeah, I see it
Yeah.
for sure. Very nice. Awesome. Thank you all. That is a very, very cool demo. I just want to get a shot of your interface. So you are controlling all these by way of these potentiometers, is how you're moving the continuous things.
And the fertilizer and water are enabled by 2 push buttons on the
2
right.
push buttons on there, drop the fertilizer and water. Very cool. Awesome. Thank you so
Thank
much.
you.
That's really neat.